In an aging global population, dementia stands as one of the most significant health challenges of our time. This progressive neurological disorder affects millions worldwide, with numbers climbing steadily as demographics shift toward longer lifespans. While researchers have identified various risk factors for dementia, from genetics to lifestyle choices, emerging evidence suggests that cholesterol, specifically low-density lipoprotein cholesterol, LDL-C, may play a more crucial role than previously understood. Recent findings from South Korean researchers have shed new light on this relationship, suggesting that maintaining optimal cholesterol levels might serve as a protective factor against cognitive decline. This research adds another dimension to our understanding of dementia prevention, potentially offering new strategies for reducing risk through cholesterol management. Cholesterol often receives negative attention in health discussions, yet this waxy substance serves essential functions throughout the body. It forms integral components of cell membranes, contributes to the production of steroid hormones, and facilitates bile creation in the liver, all vital processes for normal physiological function. However, the relationship between cholesterol and health follows the principle that too much of a good thing can become problematic. When LDL-C levels rise excessively in the bloodstream, these molecules can accumulate in arterial walls, forming plaques that narrow blood vessels and impede blood flow. This process, known as atherosclerosis, increases the risk of cardiovascular diseases, including heart attacks and strokes. The connection between cardiovascular health and brain health has long been established, with vascular damage representing a known risk factor for certain types of dementia. What has remained less clear is the direct relationship between cholesterol levels and dementia risk, with studies yielding inconsistent results over the years. The recent large-scale study published in the BMJ Journal of Neurology, Neurosurgery and Psychiatry offers compelling evidence for cholesterol's role in dementia risk. The research team analyzed data spanning more than 3 decades, 1986 to 2020, from over 12 million individuals across 11 medical centers in South Korea. For their detailed analysis, researchers narrowed their focus to compare 2 distinct groups: nearly 109,000 individuals with LDL-C levels exceeding 130 mg/dl, and an equal number with levels below 70 mg/dl. This design allowed them to examine the relationship between cholesterol levels and dementia outcomes with statistical rigor. What they discovered provides valuable insight for both medical professionals and the general public. Individuals maintaining LDL-C levels below 70 mg/dl demonstrated a 26% lower risk of developing all-cause dementia compared to those with levels above 130 mg/dl. More specifically, the risk reduction for Alzheimer's disease, the most common form of dementia, reached 28%. Perhaps most intriguing is the discovery of what appears to be an optimal range for cholesterol levels. The study found that the protective effect begins to diminish at extremely low LDL-C levels. Those with levels at 55 mg/dl experienced only an 18% risk reduction, while individuals with levels below 30 mg/dl showed no significant protection against dementia. This finding challenges simplistic lower is better approaches to cholesterol management, suggesting instead that there may be an optimal window for LDL-C levels when it comes to brain health. Beyond examining cholesterol levels alone, the research team investigated whether statin medications, commonly prescribed drugs that lower cholesterol, might offer additional benefits for dementia prevention. Their findings suggest a potential synergistic effect. Among individuals with LDL-C levels below 70 mg/dl, statin use correlated with an additional 13% reduction in dementia risk and a 12% lower risk of Alzheimer's disease compared to non-users with similar cholesterol levels. Interestingly, this additional protective effect followed a pattern similar to that of LDL-C levels themselves. Statins provided smaller benefits for those with higher cholesterol levels and showed no significant additional protection for individuals with LDL-C levels below 55 mg/dl. However, reviewing physicians have cautioned this observational study cannot establish a causal relationship between statin use and reduced dementia risk. The association observed may result from other factors not fully accounted for in the research design. This caveat reflects the broader challenge in dementia research. The condition develops over decades, influenced by countless variables, including genetics, environment, lifestyle, and co-occurring health conditions. Teasing apart these factors requires careful interpretation of observational data. While the statistical associations identified in the South Korean study are compelling, understanding the underlying biological mechanisms strengthens the case for causality and informs potential interventions. According to the researchers, elevated LDL-C levels may contribute to dementia risk through several pathways. First, high cholesterol promotes inflammation, a process increasingly recognized as central to neurodegenerative diseases. Second, it increases oxidative stress, damaging cellular components, including those in brain tissue. Third, excessive cholesterol disrupts the delicate homeostasis of cholesterol within the brain, which operates somewhat independently from the peripheral circulation, but can be influenced by systemic levels over time. Reduced LDL-C levels, conversely, appear to decrease dementia risk by minimizing atherosclerosis and cerebrovascular disease. With healthier blood vessels, the brain receives optimal oxygen and nutrient delivery while removing waste products efficiently. Process is essential for long-term cognitive health. Statins may offer additional protection through mechanisms beyond simple cholesterol reduction. These medications improve endothelial function, enhancing the performance of cells lining blood vessels. They also appear to reduce neuroinflammation directly and may help regulate the metabolism of beta amyloid, the protein that accumulates abnormally in Alzheimer's disease. Furthermore, other reviewing physicians have noted that these neuroprotective effects suggest statins may benefit brain health through anti-inflammatory or vascular mechanisms beyond their cholesterol-lowering action. The South Korean study offers several methodological strengths that lend credibility to its findings. Its massive sample size, over 12 million individuals initially, with nearly 220,000 in the final analysis, provides statistical power rarely achieved in medical research. The lengthy follow-up period captures the slow development of dementia, and the inclusion of data from multiple medical centers enhances generalizability. Nevertheless, important limitations warrant consideration. As an observational study, it cannot definitively establish causation, only association. Individuals with lower cholesterol may differ from those with higher levels in numerous ways not fully accounted for in the analysis, including diet, exercise habits, socioeconomic factors, and overall health awareness. Additionally, while the study controlled for various confounding factors, the complex interplay between cholesterol, cardiovascular health, and brain function means that isolating the independent effect of LDL-C remains challenging. The findings also raise questions about population-specific effects. The study focused on a South Korean population, potentially limiting direct application to other ethnic groups with different genetic backgrounds, lifestyles, and environmental exposures. Despite these limitations, the study offers valuable guidance for individuals concerned about maintaining cognitive health as they age. First, it reinforces the importance of routine cholesterol monitoring as part of comprehensive health assessments. While US guidelines consider LDL-C levels below 100 mg/dl healthy, this research suggests additional cognitive benefits might accrue at levels below 70 mg/dl, though not necessarily at extremely low levels. Second, it supports current cardiovascular health recommendations that emphasize lifestyle modifications to maintain healthy cholesterol levels. A diet rich in fruits, vegetables, whole grains, and healthy fats, particularly omega-3 fatty acids found in fish, nuts, and olive oil, forms the foundation of cholesterol management for most individuals. Regular physical activity further enhances cholesterol profiles while offering additional benefits for brain health. Exercise improves blood flow, reduces inflammation, and stimulates the production of growth factors that support neural health, creating a virtuous cycle of cardiovascular and cognitive protection. Those unable to achieve optimal cholesterol levels through lifestyle modifications alone, the potential cognitive benefits of statins add another consideration to the risk-benefit analysis of these medications. However, current evidence does not support prescribing statins solely for dementia prevention. These medications should be used according to established guidelines for cardiovascular disease prevention and treatment, with potential cognitive benefits viewed as a secondary consideration. Weight management and control of other conditions like hypertension and diabetes remain crucial components of a comprehensive approach to reducing dementia risk. These conditions interact with cholesterol metabolism and vascular health, potentially amplifying negative effects when poorly controlled. The South Korean study represents an important step forward in understanding dementia risk factors, but many questions remain unanswered. Future research efforts will likely focus on several key areas. Randomized controlled trials examining the impact of cholesterol-lowering interventions on cognitive outcomes would provide stronger evidence of causality than observational studies. Such trials present significant challenges, requiring large sample sizes and extended follow-up periods, but would substantially advance our understanding. More detailed investigation of the mechanisms linking cholesterol and brain health could identify potential targets for intervention beyond simply lowering LDL-C levels. This might include exploring the role of different cholesterol subtypes, examining how peripheral cholesterol levels influence brain cholesterol metabolism, and investigating interactions between cholesterol and other risk factors. Research into personalized approaches to dementia prevention also holds promise. Genetic factors, pre-existing conditions, and individual metabolic profiles might influence the optimal cholesterol range for cognitive protection, suggesting that blanket recommendations may eventually give way to more tailored guidelines. While the connection between cholesterol and dementia risk represents an important piece of the puzzle, it exists within a broader context of modifiable risk factors. Recent research suggests that up to 40% of dementia cases worldwide might be preventable through addressing factors including physical inactivity, smoking, poor diet, excessive alcohol consumption, and inadequate management of conditions like diabetes and hypertension. This broader perspective reminds us that isolated interventions targeting single risk factors rarely provide comprehensive protection. Rather, a holistic approach addressing multiple aspects of physical and mental health offers the strongest defense against cognitive decline. Social engagement, intellectual stimulation, quality sleep, and stress management complement physical health measures in supporting brain function throughout life. Educational attainment and cognitively demanding occupations appear to build cognitive reserve, a resilience that helps maintain function even when brain changes occur. The South Korean study adds valuable evidence to our understanding of dementia risk factors, suggesting that maintaining LDL-C levels within an optimal range, not too high but not extremely low, may help protect cognitive function as we age. Potential additional benefit of statin medications for those with moderately low cholesterol levels offers another intriguing avenue for investigation. While these findings require confirmation through additional research, they align with existing recommendations for cardiovascular health. This convergence of cardiac and cognitive benefits reinforces the interconnectedness of body systems and the value of holistic approaches to health maintenance. For individuals concerned about dementia risk, maintaining healthy cholesterol levels through diet, exercise, and medication when necessary represents one important component of a comprehensive prevention strategy. Working with healthcare providers to monitor cholesterol levels and address other risk factors provides the best foundation for long-term cognitive health. As our understanding of dementia risk factors continues to evolve, the empowering message remains consistent. Many of the actions that support overall health also protect brain function. By making informed choices today, we increase our chances of maintaining cognitive vitality throughout our lives.